Volume of rectangular prisms. The vocabulary for volume is the number of cubic units needed to fill a space occupied by a solid. So, you know, we gotta get Steve.
Volumen. Cantidad de
That's
unidades
not
cúbicas
Steve.
necesarias para llenar el espacio ocupado por un cuerpo.
That was Javier. Thank you, Javier. He was a little jealous. He wanted to get in on this too. But we know. We need Steve too.
Volume. The number of cubic units needed to fill the space occupied by a solid.
Alright, thanks Steve and Javier. Appreciate it. So back to volume. Alright, so here is a rectangular prism. It's square base. No, it's not a square. Rectangular base, and then it has 4 lateral sides, all parallelograms. And volume is just basically all the little cubes that are inside of here. One of the things we'll notice that there's 1, 2, 3, 4 on the side here. We got 1, 2, 3, the depth, and then we have 1, 2, 3 as the height. There's a few ways of solving it. One way, we'll take the bottom off, we'll take the top off, and then we also have the middle. And we won't do that. One way we can do it is we can just start counting all the little squares. We have 1, 2, 3, 4. We got this guy 5, 6, 7, 8, 9, 10, 11, 12. So we know that we got 12 in this one. Do the same here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm gonna guess that there's 12 in here, but let's just double check. Well, there's 4, and we got 5, and we got 6, and we got 7, and then we got 8, and then we got 9, and then we got 10, and we got 11, and we got 12. I'm a psychic. So what are the number of cubic units needed? They're needed because they're needy to fill the space occupied by the solid. And yes, still, what's on the inside matters. So there are 12 in here, 12 in here, 12 in here, 12, 24, 36. So there are 36 teeny tiny little cubes, whatever they are. So cubes. Since it's volume, it's got to be to the 3rd power. That's an ugly 3. That's better. To the 3rd power. So cubes third to the 3rd power. That's one way of doing it. Let's get rid of all this real quick so that we can get those back together and make life easier for me. So boom, boom, boom. There we go. It's one way of doing it. Another way. Let's take the bottom. Move it off. Count them up. We know there's 12 in here. There's 12 of these little cubies in here. And we have 1, 2, 3 layers. Like Trident, they have layers. And we know that 3 times 12 is 36 as well. 36 cubes. Cubed. That's a mouthful. So, and one more way. And put that back there. Alright. Got a little mole here. Gotta get rid of that mole. There we go. There's one other little way. We know we have 1, 2, 3, 4. So we know that this part right here is 4 cubes. And then we have 1, 2, 3. We know that this part right here is 3 cubes. And then we have 1, 2, 3. And we know that this part right here is 3 cubes. So what we can do, since we know repeated addition is multiplication, 4 times 3 times 3. Well, 4 times 3 is 12, and we already knew that the entire base of this was going to be 12. And then we have 12 times 3, which is 36 cubes cubed. 3 ways of doing it. There you go. So example numero dos. We got this one right here. Many different ways of doing it. Let's do it the easy way. 1, 2, 3, 4, 5, 6. So we know one side is 6. I'll go to blue. We know that's 1, 2, 3 times 3. And red. We know let's cut it from here. 1, 2, 3. It doesn't matter where the height is, but we know it's 3. So we know that 6 times 3, good old 18, drop down to 3. And 3 times 18, well, 8 times 3 is 24. Then we get rid of the 2. 3 times 1 is 3 times 2, 3, 4, 5, 54. So on this one, we get 54 cubes cubed. There we go. We could have broke it apart, counted up all each individual cubes. We could have just lowered the base and then make copies of that. But this way, I believe, is the easiest. Now, what happens if we don't have cubes? Well, life is easier, derp. Alright, so I know this side's 5. I know this side's here. Side here's 4. And we know the height is 7. Multiply them all together, because we know that already. 5 times 4 is 20. Times 7. That's an ugly 2. Hold on. Time out. Slow it down. Slow. That's purty. You know, I cross the zeros out. And 20 times 2. Well, we know what 2 times 7 is 14. And we just add the zeros, so 140. In this case, we do have inches. Inches? What the fraction? Inches. Centimeters. Centimeters. Centimeters cubed. So yes, I put the chicken in the oven as well. So centimeters cubed. So there's 140 of these little centimeters that are inside of this little big, yeah, rectangular prism here. So there you go. Moving on. That was Sven. Sven. Hi, Sven. So what we found out, volume is just the length times the width times the height, also written like this. Usually the L isn't written like this. Usually you'll see it'll be all fancy. Fancy L. We need the fancy L. Width times the height. That's it. So my question is right here. Plain and simple. Taking a look at this insane Rubik's Cube, which I know some of you want. Like, mommy, 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 mom, 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 ma, ma, mama, mama, mummy, mummy, mummy. I want this Rubik's Cube, please. What I want to know, in this Rubik's Cube, there are these little teeny tiny little cubes here. It's fun again. So like this little teeny tiny cube right there. So we have this cube right here. See? It's a cube. It's a cube. This cube. This cube. How many of those little cubes make up this big cube? That's my question for you. How many little cubes? How many total little cubes are in here if you were to explode it and then throw it on the ground? How many little cubes are you going to have to pick back up? That is my question. Okay? Okay. Bye-bye.